Hello, welcome to this session, Voice over Stellar Wireless LAN Design Guidelines. The voice support is a must-have for any business wireless LAN solution. It allows people to be connected and reachable at any time, and it is evolving today with a growing range of multimedia equipment and UC functionalities. In this presentation, I will focus on a key point of voice over wireless LAN design to respond to this evolution for connected equipment. Let's take a look at the agenda. First, we will review the architecture and features of voice over stellar wireless LAN. We will detail the roaming and the QoS, which are the fundamentals of voice over wireless LAN. We will highlight the key point of a voice design on the 5 GHz wireless band. We will show the configuration and the monitoring for voice with OmniVista 4.6. And finally, we will have a quick overview on convergent network and communication stellar voice solution version 7.2. The support of voice over wireless LAN requires a highly available, secure, and scalable Wi-Fi network. From a component point of view, core, edge switches, and stellar access points are all provided by AELI. At communication side, servers, voice gateways, UCAS Rainbow clients, 8168S wireless LAN sets are also provided by AELI. The edge switches must be PoE++ compatible to power the last Wi-Fi 6 access points. IP clusters operate as local distributed wireless controllers. Clusters are made of interconnected AP to provide an enterprise-class unified wireless services through the site. No need of virtual machine controller, dedicated RF domain. Any stellar cluster can work without OmniVista or OV-Cirrus active. From a management point of view, the architecture is based on the centralization of management with OmniVista 2500. In addition to the IT server, appliances allow the physical redundancy of OmniVista server in a high availability mode. The OV-Cirrus and Express management modes are also supported for voice. Benefits provided by OmniAccess Stellar solution are the support of the latest .11ac, 11ax technology through the site, a unique mobile environment, users roam freely through the site without interruption of voice and audio-video service, the use of a single voice policy that can be based on the existing IT, for example, existing Radius or ID server. The voice usage can be viewed on OmniVista with a visibility application for voice, audio, and video. The site performance can be monitored on coverage, cloud concentration, roaming, heat map, etc. With this table, you have an overview of voice features on stellar WLAN with a comparison per stellar models, Wi-Fi 5 and Wi-Fi 6. What is interesting to note is different management modes supported, the support of PoE existing edge infrastructures. The voice is supported on both 2.4 and 5 GHz radio bands, with support of latest .11ac and 11ax standards, and with a complete client RF control in all bands. The type of roaming, including .11r, 11k, and 11b standard for smartphones. The QoS and links, the deep packet inspection, the DPI, in almost all stellar models for application visibility monitoring and enforcement with OmniVista. In terms of performance, we can know the number of simultaneous calls obtained on the 5 GHz band for the Wi-Fi 6 access points. And we can note also features supported by advanced OmniSwitch 6860E and 69 series, such as SIP and the HTTP snooping, and the support of voice metrics, such as measurement of the MOS, a factor, the delay, etc. in real time. This slide depicts the voice over RAP Stellar, which is a topology that particularly impacts the network end-to-end. Voice here is supported by a Stellar AP installed at a remote site. It can be a remote branch office for the company or just a home installation. The AP is then configured as a remote AP and is managed via OmniVista 2500 from the main office. RAP automatically establishes a VPN tunnel to the VPN appliance server installed at main office. Two modes for RAP Stellar for voice. The full QLAN mode, where all of VoIP traffic is sent back to the main office and to the communication server. A local routing mode, defined for the remote site, with transfer of VoIP packet locally between local voice users. UC applications require traffic back to the internet and routing to the internet. A broadcasted SSID in a remote office has the same configuration as for a campus SSID. A segmentation for voice can be defined in OmniVista to make possible the monitoring of VoIP from the main office. Fast roaming with .11r. When a device goes from an IP to the next with the .annex protocol and reduced in enterprise mode, basically the authentication is completely reconnected to associate with each new IP with the same master key. A new full heap and heap over the LAN exchange consumes time in .1x. To simplify, with 11r, the Stellar IP will inform in advance the next IP that the device is roaming, and is give a key index to the new IP. The roaming equipment does not need a full re-authenticate to calculate the new key, and obtains a significant time saving to associate. Benefits with a reduced server is an optimized roaming with WPA2, WPA3 in enterprise, and a QoS block time generally below the 50 milliseconds, equivalent of 2 packets or 2 video frames in time. Otherwise, roaming depends on device roaming capabilities and gives breaks of 200 milliseconds via the OKC method and up to 6 seconds without any method. Recent smartphones and handsets support the 11R, and if 11R is not enabled on an SSID, most chipsets in the market can still fall back to the WPA2 or WPA3 passphrase methods. Improve the roaming performance for smartphones. What is the best IP to associate for an Apple or Samsung smartphones? The .11k protocol assists smartphones when they seek to roam to a new IP. This slide shows a WLAN beacon report provided by IP at each client association. The client then scans the received channels and RSSIs and chooses the best IP according to its own criteria. The .11v protocol assists smartphones for best IP in the form of solicited requests from a smartphone itself. It will help in case of difficult RF environments, when the RF context is not known, or when any RF change in the Stellar infrastructure. 11K and 11V are supported on recent smartphone version, iOS 8 or above for Apple, Android 10 and above for Samsung Galaxy Note. It is very important to note that 11K and 11V are continuously evolving to take into account difficult RF environments, such as an IP not seen, for example, during roaming. Apple with iOS 11 or 12 is the first to adopt the evolution of both standards. Most manufacturers now follow Apple and support that 11K and V. It is therefore recommended to update equipment for their support. For BIOD devices and laptops that do not support 11K and V, they should interoperate with SSID where 11K and V are enabled. The roaming depends on the client capabilities. About QoS process for VoIP on Stellar WLAN. For optimum experience with phones and smartphones associated to Stellar IP, it is essential to implement the correct end-to-end QoS in the network, or a QoS closest as possible to the equipment. Wi-Fi multimedia .11e certification allows this interoperability between different vendors by defining the correct QoS marking and correct prioritization for voice, audio, video stream on the wireless LAN. First, WMM queuing and then Wi-Fi prioritization on the air, upon a mapping with L2 and L3.1p DSCP LAN marker. That is what we see in the table where 3 categories are defined for the VoIP: best effort for smartphone applications, and voice video for pure voice applications. UAPSD provides battery saving features that provide acceptable battery life for business phones. All handsets support UAPSD to deliver high talk time and standby time. Then Stellar Wi-Fi 6 IP have a dedicated radio for scanning that avoid interrupting active Wi-Fi channels during any VoIP traffic. The Deep Packet Inspection feature, or DPI, available on Stellar IP and OmniVista application visibility, allow to monitor VoIP application from the layer 2 to the layer 7. Configure the application visibility in OmniVista will enable to monitor with detailed view all VoIP applications. Additional control and enforcement can be added if necessary. Three signatures are at disposal for VoIP in OmniVista. A rainbow signature for Rainbow Client, a SIP RTP signature for smartphone with SIP client or Alien set in SIP mode, and a UI UDP signature for software client on laptop or Alien set in NOE mode. On this slide, for reference, some values are given for the maximum bandwidth consumption of voice, audio, video application by Stellar IP, with an equivalent in number of simultaneous communication per access point. The voice quality is generally measured on the basis of a R-factor at least greater than 80. We can note that the bandwidth consumption of up of 100 megabits can be ensured by the Wi-Fi 6 Stellar access point. Design on the 5 GHz wireless band. First of all, let's remind what are the objectives of a RF design for voice on the 5 GHz band, with voice, audio, video equipment. To keep the best possible voice quality through the site, the coverage must make possible to maintain a RSSI above minus 70 dBm to maintain a voice communication. A low channel utilization is necessary to guarantee the bandwidth. A high channel utilization is an indication of interference, lack in resource, or a loss of access point. For the network performance, it must stay below the indicated value for the delay, jitter, packet loss, and retransmissions. They are the guarantee of a sufficient QoS in the network. For equipment with roaming capability, a 20% cell overlap in indoors is required on the 5 GHz band. That gives basically an IP density of 1 IP per 225 square meters of area working with 11AC or 11AX. This type of deployment provides minimum throughput of 10 megabits for any voice and data users, up to 100 megabits by addition of IP. Both pictures on the slide represent this type of coverage with the same density of IP. When RTL Stellar geolocation services are requested at the same time as the voice, audio, video coverage, for any inventory and tracing requirements in the same area, placement constraints requested by BLE beacon must be taken in account. Correct IP placement enables correct triangulation and acceptable accuracy for the geolocation. This is done via a zigzag deployment pattern close to an hexagonal deployment. The site survey answers the question of the placement of the IP. It is essential. How to place the IP for an optimal coverage for the VoIP. There is 3 different survey tools to help. The planner that provides a placement simulation based on coverage parameters, antenna, and no RF obstacle. The passive on-site survey, which allows a real measurement of on-site coverage. The spectrum analyzer that identifies RF signals that can interfere with the WLAN. This slide shows on-site measurement methodology carried out with harmonic tools during a site survey on-site. 3 parameters are selected: signals, power, and data rates. When moving, the harmonic tools indicate if threshold exceed, and then define the range of the size. OmniAccess Stellar Wi-Fi 6 access points support the 11AX standard and will help to scale the Wi-Fi network with the voice, where the number of voice, audio, and video clients and the demand in bandwidth is important. VoIP clients are sensitive to the network latency, and thanks to the Wi-Fi 6 OFDMA features, this latency is optimized with the Wi-Fi 6 Stellar access points. UCAS clients are typical equipment requiring high audio-video bandwidth, and the Wi-Fi 6 MIMO share this bandwidth with the most recent smartphone. On this slide, adding a Wi-Fi 6 access point to an existing installation doubles the WLAN capacity by doubling the IP density. This without changing the existing placement. 2 or 3 best practices for the channel management on a 5 GHz band with roaming equipment, which is therefore sensitive to channel availability. Prefer the 40 MHz channel wide because it provides 10 channels for roaming. Depending on the country, a certain subband 102, 134 is authorized or not for indoors. OmniAccess Stellar takes into account local regulatory for the indoors use. Always for the subband, difficulties can be encountered, with possible interference with radar, weather station, or even satellites. It is recommended to do a list of channels to avoid these problems. I do not review or already known SSID advanced setting for voice with a Stellar 402. UNP profile for voice is recommended for any advanced configuration. WIPS feature is managed for the wireless security. New settings with release 403. The UAPSD to be activated for island sets that support the UAPSD power save. The FDB update on association to be activated also to update the OmniSwitch forwarding port upon IRP generated during the client roaming. It will be used on the left side for location services to know where is the device connected. For all equipment supporting voice, as discussed before, the .11r, 11K, and 11V roaming set is activated. QoS for smartphone. Filtering on wireless IRP is enabled. I applied the SCP.1p LAN markers for the WLAN best effort category. For RF configuration associated with the voice IP group, the RF settings are set for France for indoor WLAN. The settings remain identical to OmniVista 453. Enforcement to the 5 GHz band and airtime fairness are activated. The roaming is carried out at 70 dBm. To comply with indoors regulation, I use the FSTPC features to readjust transmission power over the entire 5 GHz band. I do the same for the .4 GHz band also. The 40 MHz bandwidth is by default. MIMO and .11ix settings are enabled. Voice monitoring in OmniVista. From a WLAN home page, we can monitor clients through different widgets: wireless client distribution, across frequency band, or across IP, client bandwidth consumption, and client health widget. Using the client health widget, we can do a SSI and roaming historic on each client. In this example, in real time, we check the correct coverage of a Huawei Pro smartphone while roaming. From LAN point of view, from the global home page, we can have a view of top-end VoIP application and bandwidth consumed for each. Here the example of Rainbow client and Alien sets. I have no 6860N switch on the platform to add real-time voice metering in my monitoring. With the RF scanning activated on Stellar IP, we can also view in real time the utilization of the 5 GHz channel through the site. Here in this video, I am connected to the web page of AP Module A and to the scanning console on the 5 GHz band. We can see in real time the use of non-DFS and DFS channel under the UNII1 and UNII3 subbands. Those channels are all used for voice. With only few voice equipment connected, there is no channel overutilization. What is Voice over WLAN 7.2? Voice over Stellar WLAN is a certified solution. We are now in iteration 7.2 for Stellar WLAN. You will find in detail the points explained before in the Stellar Data Communication Convergence Voice document, using the link indicated on the slide. You will find in particular all supported topology on OmniAccess Stellar. The second part of the guide covers the deployment for the specific use case of hospital. The guide includes with equipment description, the technical documentation, the datasheets, manual, and application note. All links are in the documentation. This table gives an overview of the test report on the MP6 Enterprise and Office Communication Server for collaborative clients with voice on Android mobile and on iOS mobile, for ALE81, 58, and 68S business handsets, and for other non-WLAN handsets and non-smartphone supporting voice on the market. ALE handsets are under the Premium Consumer Support Process, and other voice equipment are part of the DSPP program. Each interworking report provides the status of testing for each equipment. This report list is regularly maintained and updated on each iteration of the documentation. This slide shows the Stellar lineup for voice, which is indoor and outdoor. Any cluster, any Stellar models support in all mode, Express or OmniVista, all roaming standards, then the 11R, 11K, and 11V, and it manages the QoS with the WLAN multimedia. With a model that supports the Wi-Fi 6, the 4x4 MIMO provides up to 4.8 gigabit wireless throughputs for the smartphones. The Wi-Fi 6 can support up to 512 clients per radio. OmniAccess Stellar Wi-Fi 5 and Wi-Fi 6 can be mixed, and the DRM RF manager of OmniVista is common for the both standards. The DRM manages channel for multimedia, including bandwidth selections, channel selections, and power transmissions with the DFS TPC features. All OmniAccess models equipped with DPI allow with OmniVista the advanced monitoring and the analytics for the VoIP. In conclusion, we have seen in a broad outline how to design, how to build and operate real-time voice services on OmniAccess Stellar. OmniAccess Stellar is a highly available, scalable and multi-site distributed architecture with a full control of voice, audio and video equipment at wireless level. It responds perfectly to all types of sites, from small ones to multi-site ones. The site survey remains essential to detect difficult RF environment. It is the case in particular of the hospital environment. This survey is systematically proposed by AED for any new deployment project. We have seen also that the configuration is essentially done at SSID level and at RF level, and it is almost ready for voice. We have also seen that voice monitoring can be easily done with OmniVista from the LAN and the WLAN home page or directly via the IP web. Finally, we have seen two categories of equipment certified by AED, business handset and business smartphone. That brings me to the end of this session of Voice over Wireless LAN Design Guideline. I hope you find it useful. Keep enjoying your Spacewalker live event. I am looking forward to interacting with you on the Spacewalker platform. Thank you for your attention, take care, and see you soon.